Hi everyone, welcome to the channel. This week we're going to talk about designing and making your own custom bus bars. Let's get to it. All right, today we have a wall charger from the company Enderman. Looks like some hardware to hang it on the wall. Look at that, that looks really nice. I love it when they come with kind of like this dust cover. So this one is the hardwired version. It is nice that they've got a nice flexible cord coming out of it. But anyway, I thought it was really nice. You don't have to dig into this to make that connection. All right, time to download their app. So we'll go ahead and add device. Try energy. Yeah, I think that's the one. I don't have space next to my outlet in my new garage, but in my old garage, I've got lots of space. So we're gonna go ahead and hang this one up here. Pretty clean installation. I'm sure the plastic on the outside is meant for just packaging, but I'm gonna keep it on, you know, so if I drag it across the floor or whatever, it'll kind of stay clean. So unlike other chargers I've seen, this one when you plug it in, it does not automatically start. You start it from the app, just like that, and it'll start charging. I heard my car click on. And this one should ramp up to about 11 amps. That's what my onboard charger will do. And there you have it. And if we want to turn the charging off, we just click there. We could also unplug it. Or this charger also has an emergency stop button. Just like that. This is end of charging. Gives you the total charge time, a full 1 minute. All right, here's what it looks like a little over an hour in. Again, this is limited by my onboard charger at 11 amps, but this unit can actually go up to 50 amps. Here we are the next day, all charged up. Enderman Level 2 50 amp wall charger is 9 times faster in charging speeds, and it has a smart app control. The max 12 kilowatt charging output gives you up to 37 miles of range added in an hour. The smart app control allows for remote control, set timing, current adjustments, charge time management, charging statistics, 3 types of networking, and 2 RFID cards. Real-time monitoring of charging, ultra-low energy consumption, LED ring light to remind charging status and abnormal conditions. It is ETL certified, more durable, and lower electrical safety hazards. Has a 25-foot ultra-long charging cable, suitable for various garages and parking environments. If you are interested, please check out the links and coupon codes in the video description below. I'm on my own, broken alone. I feel the rain. This week I'm going to walk you through what I'm going to call phase 1 of the battery box build, which includes custom bus bars. For those who are new, we're going to make this car all-wheel drive. We're going to put dual motors in it, and it's going to be completely electric. So we are at the point in the build where we are getting things put back together. So today we're going to be looking at a lot of the electrical connectors and especially bus bars. Bus bar is really just a term that electrically connects one area to another, usually with kind of a solid piece. I'll put a link to a video here. This is where I designed my battery box and where I really kind of said this is where I'm doing bus bars. So that's kind of where I came up with the bus bar designs. As you can see here, this is the battery pack, and you'll see that the terminals are connected with solid components. So what I did is I made drawings and actually sent them to a couple companies to quote and bid. What I was looking for 99.9% copper that was nickel plated. I wanted a specific size to be cut out, and I also needed some bends. These components, along with some other connectors, came in. I just want to show you what I got. Oh yeah. This is so awesome. You can open these bus bars. They look magnificent. So these are pure copper that are nickel plated. So the nickel plating helps keep the copper from corroding and still provides really, really excellent electrical properties. I'm going to lay out all the bus bars here. So here's 3D printed version, here's the real version. Again, 3D printing is a great prototyping method to make sure you got the right geometry. So I believe I only need 56 of these. I ordered 60. These ones go to all the battery terminals, and the rest of these just connect those battery terminals to where I need them to go. So a lot of these are just linking one battery to the other. This is linking 4 battery modules together. I think they did a really good job with all the bends. I've got kind of QC data that they took all the measurements according to my drawings. So that looks pretty good. Again, these are all copper, nickel plated. I know some people might be interested in doing this, and I actually chose a Chinese company, and I think it turned out really well, and each one was less than $7 a piece. Beyond all the bus bars, I also got a whole bunch of connectors. So this is one type that I got. Call them Deutsch connectors. It comes with all the pins and call them receptacles to clip into these. These are weather resistant or weatherproof. It comes with kind of a sealing ring, a jam nut. I've even got plugs, a lock washer. This is a removal tool. These are really secure, really good units. And basically put them here, and then this one kind of rotates and locks in place. So I've got 4 of these. These are going to go in and out of the battery box for thermistor wires and cell taps. So these are the same things, just bigger. I think the other one had 21 wires. This one has 31 wires. I got 2 sets of these. These are the high voltage connectors. One will be for the front motor, the other will be for the rear motor coming from the battery box. As you can see, there is some assembly required. So I'm actually going to cut, splice, crimp the high voltage cables to these lugs here. They get then assembled into the plug here. This is the receptacle, and this will actually be in the battery box. So it'll be mounted to the battery box, and the bus bars from the battery box will be connected here. This is the high voltage interlock loop. So that's what these wires are for. So basically these wires will get fed to the BMS so it knows at any time if a part of the high voltage system is disconnected. And the way these ones work, again, once they're all assembled, put this here. Like so. This one has kind of a 2-step to unlock it. You have to pull this one down and then pull that one up, and that releases it. And again, it's got a really tight kind of weather seal. The previous connectors were for, I believe, 90 millimeter squared cables. These ones are for 120 millimeter squared cable. That one's taking, say, half or 3/4 of the battery power to go to the front or to the rear. This is the full battery power going from kind of one part of the pack to another. Like so. Again, this one's got a 2-step lock where you have to push that one forward and then down. Like the other one, this one's got some assembly required. And look at that lug. But again, it's got 2 pins for the high voltage interlock. So this connector is rated for about 300 amps continuous, and again, 90 centimeter squared cable. This one's rated for about 500 amps continuous and 120 square millimeter cable. This one's got a place for 6 connections, and this is a 2.5 centimeter squared connector, and I believe it's rated up to, I can't remember, it's either 30 or 50 amps. But this will be for all the smaller high voltage items like an AC compressor, cabin heater, things like that. Again, all these have really good weather seals. They are all HVIL, so again, the high voltage interlock. But these are all the cell tap wires. This is the pre-charge resistor. These are the economized contactors. Got the massive fuses, pre-charge relay. So I think that does it for all the kind of electrical components for the battery box. My plan to put all this together is I wanted to actually coat these, make them as safe as I can. So I'm going to put a rubberized coating on, but first I have to kind of place all the batteries exactly how they should be. I want to connect all the bus bars, cinch them down tight, then take them off of the battery modules, coat them, and then those bus bars will be complete. We can kind of take them on and off, and we can move to the next part of the build. I've been covering up my batteries when they're not being worked on. Just keep things, all the dust and debris off. Before we get started with the battery modules, I just want to make sure we're clear. Today we are not going to be working on a high voltage system. So each one of these battery modules is only about 24 volts and is usually considered pretty safe to handle without any safety equipment at all. Nevertheless, we're going to wear gloves and be as safe as we can. All right, these are the bus bars that connect the battery modules to the other bus bars. You can use cabling. For me, I just thought it was easier, more compact to use just bus bars. I'm going to configure these battery modules like they're going to be in the rear battery pack. So I'll do that real quick and then we'll start attaching the bus bars. Next, we're going to connect these bus bars. Again, we want to keep things tight. I've designed things to be pretty tight, so there's actually a bar that goes here, so meaning the bus bars will not go on top, they'll actually go underneath, then there'll be bus bars going up and down. So I just need to make sure that I've got these in the correct place. I've got one here, and then essentially a U, and then another U. This one is what I call the main battery box. So for this first one, this is now in place and I'm going to remove it from the battery and then I will dip this whole section. So everything but the parts that are connecting to the battery terminals themselves will be kind of isolated. All right, I put this on just to kind of keep everything together. When everything's said and done, again, I'm going to put nuts and washers kind of in between there just so things don't move, but just doing this real quick. And again, the thought is if I can get all these kind of in position and then lock them down, I can take this off and dip this whole thing and then just put it back on. These are all tight now, and the thought is I can take this off, dip it, and then put it right back on. So I take it off, I'll dip it with everything tight. Then be able to put things back on, tighten everything down. I am going to be using a substance called Rubberize-It. So I checked with this company. It is specifically made to bond to metals. I've got their cure schedule and everything I need to do to process it correctly. And at the end, we'll even test it. Here is a portion of the bus bars that I'm making. This is the Rubberize-It rubber coating that I'm going to use to make sure things are kind of electrically isolated. So I'm going to mix that up, get it ready. I've got a little container there to pour it in, and then I'm going to dip these, set them here to dry. Recoat time is 4 hours, so I'll probably do at least 2 coats to make sure we got good thickness. Whoa, this is supposed to look orange, by the way. All right, we're gonna give it a go. The consistency is about kind of like house paint. I was thinking maybe it'd be a little bit thicker, so it may do more than just 2 coats, but we'll see how it goes. It makes me wonder if you could spray it, because I think that'd be way faster. This probably gives you more coverage. A little thicker this way. Got the first layer on, basically just dunked it, let most of it drip off and drain off, and then just set it down and it'll cure. Again, recoat time is about 4 hours. I do want to show you, so I think the, I'll call it like top surface will give it a really good coating and thickness, but you can see, like, I'll call it like the edges are gonna be a little bit thinner. So definitely gonna have to do multiple coats, make sure I get those kind of corners nice and electrically isolated. All right, here we are after the first coat has kind of cured. Again, in general, I think it looks really good. I'm really pleased. The edges, like the corners, are still probably too thin. So again, I'm thinking like 3 coats or something like that. This is after, I think, 3 dips, and you can see it is not a clean process the way I'm doing it. And I still feel like we're a little thin on the very corners. I've got more of these to do. I think what I'm gonna do is I'm gonna try method number 2, which is probably spraying. All right, so I've got the parts that are going to contact the battery modules. I've got those taped off so we can keep those nice and clean. I'm going to now try to spray these. Initially, I thought dipping would be best. I thought you'd get a nice thick coating, which I think you do, but it kind of drips off, not ideally, just very, very messy. So I'm going to try spraying this, see if I like that any better. So you can see the areas we masked off. They're nice and shiny. They'll conduct very well. Everything else is coated very well. It is now time to test, though, to make sure that the product we used indeed is a good electrical insulator. I even coated a 10mm wrench here. I also made a special socket. This will allow me to tighten some of the terminals that are actually underneath. So you can see how that's underneath. It's kind of hard to get to. So that's what I did there, and this will also allow it to be electrically isolated. We have just my standard meter, so we got less than an ohm. And hopefully, when we do this, so that's really good. So we'll test over here as well. So again, that's very good conductivity. Very good isolation. All right, this is my loss of isolation meter, and if I put it at 1,000 volts and just test it in air, it'll come back with greater than 2.2 gigaohms. So we'll test it here on my wrench. So there you go, 153 mega ohms. 0.5. As far as order of magnitudes, you've got things like ohms, then you've got kilo ohms, and then we're talking mega ohms. So this is like 1 million ohms is kind of the range we're talking about. So if it's like 0.6 million ohms or 4 or 8 million ohms. So again, that resistance is pretty good. With as good as that resistance is, we still don't want these things touching anything intentionally. I do have a few more bus bars to do, but those I've got to physically assemble the boxes, do some structural things before I can get those done. So this will do it for this time. As you can see, we're getting closer. The battery box build will take a couple episodes. Today we tried to break it down into kind of bus bars and some of the electrical things, connectors. We still have wiring and cooling to go, but that'll do it for this time. See you next time.
I just replaced the battery.